okay with that. It's recording, and I am now going to introduce my partner in crime, Mike Newman. Mike, if you want to share a screen, you can. Everybody's allowed to share. And Mike is going to start by talking about the skew T log P. And they're really the same chart. They're just different aspects of the chart. And then after he's done, I'm going to go down that sheet that I showed you, and I published Mike's sheet as Mike's weather page as well. If other people have weather pages they'd like me to include in some of the broadcast after this, I'd be happy to do that. If you use particular weather pages, I'll just create a list and broadcast it to everybody. It is interesting that different people use different things. And Mike is coming up, and there you go. Okay, Mike, I'm going to turn it over to you. I refreshed all my knowledge about skew T's this morning, and I admit I use skew T's a lot. So there you go, Mike.
Well, to start with, let's just understand what the plot is. The plot is temperature on the horizontal axis and altitude on the vertical axis. Well, it's a little bit of a lie because the axis is twisted. The temperature axis isn't really straight up and down. It's really crooked, but we can ignore that for the purposes of talking.
It's why it's called a skew T. The temperatures are skewed.
It's rotated about 45 degrees if you
Yeah.
really want to know. So what's plotted on here are two fundamental plots. The red line is temperature versus altitude. So if you move the cursor to a particular height, you can read in the black the temperature at 75 degrees Fahrenheit, if you will, and you can get the altitude off the left side, 1,250 feet. And the blue line is dew point versus altitude. You don't really use that directly. It's used by the analysis to help calculate things. So if you take a parcel of air here at the surface, and I've picked 80 degrees, and look at what happens to that parcel of air. It starts at the bottom of the purple, and it rises following a line of constant energy. That's the skew part of it. You can see it's rising at about 30 degrees centigrade. And that blue line is what happens to that parcel as the air expands and cools. So if you take a parcel of air at the surface, it follows that purple line expanding and cooling until it starts forming a cloud. So the natural rate of cooling is plotted here on these diagonal blue lines. Once it starts forming a cloud, the natural rate of cooling changes. So that dew point line is being used to calculate where the cloud starts forming. And you see that horizontal black bar, that's where the cloud starts forming, and the natural rate of cooling changes. If you look carefully, you'll see black lines that are the natural rate of cooling once it starts condensing into a cloud. And what we see in the plot right here is that if it gets up to the temperature I chose and then starts rising, it'll stay warmer than that red line all the way up to where cloud starts forming, and then continues staying warmer than the red line until, I don't know, what is it, 40,000 feet or so in this, 30,000 feet. So what that will do is that'll make a thunderstorm. If it keeps on rising into the 20, 30, 40,000 foot range, that's a thunderstorm. The other thing that you can get out of this is some idea of how strong that lift will be. The strength of the lift, when you heat a parcel of air up, the amount of energy that's released as it expands and rises is the area between the purple line and the blue and the red line. So the bigger that area, the stronger the lift will be. So you get a very quick visual presentation of what's going on. So as I analyze this for a particular day, I look at the sensitivity with temperature, and I click at different surface temperatures and see what happens as the air goes up different rates. So if they tell me that the surface temperature is going to be 80, and I say, well, what if it gets a little warmer? I click on 82 and I see what happens if it gets a little warmer. So the terrain that's on the ground gets heated up to essentially the same temperature based on how much sunlight it's in. The reason higher terrain is producing better lift is that 80 degrees at 2,500 feet, well, that's 70 degrees. There's 80. So if you start that parcel of air on a higher piece of terrain, it gets a head start compared to the surrounding air. So to go through the rest of the things on this chart, there's actually a couple of other interesting things. One of the things is wind direction, and you get simple wind barbs over here in the right-hand column. And the wind barbs are the direction the wind is. These are westerlies, and the normal, each long thin line is 10 knots. A half line is 5, so this one here is 25. A triangle is 50 knots. So here we have 50 plus 4, 10 knots. That's 70 knots of wind. And so that's the wind barbs. The blue plot to the right is strength versus altitude, shows a nice, simple increasing strength with altitude. And as you move the cursor up and down, it highlights a spot on that blue line, and it highlights which barb you're opposite. So the last thing on the chart is this circle over here at the left. If you look carefully, as I move the cursor up and down, it highlights a spot on that line, on that green line in there, that's the altitude that's showing up at the wind. So that's just a polar plot of the wind. Right there, it's showing 40 knots, and it's out of the west at a little bit north of, a little bit south of west. The interesting thing about that polar plot is that it tells you how twisted up the wind is as the altitude changes. What you see in the plot today is that it's not really twisted up at all for most of the height. And then you get up here, and all of a sudden you get a big change in wind direction with altitude. Very abrupt, very big change. So the twisted up nature of that, whoops. I just clicked on too much.
Yeah, you should.
The
People need to look at different days.
Plot is telling you how much turbulence you're going to really have. The more twisted up it is, the bumpier it'll be, because turbulence at altitude is really a change in wind direction that will make the bump. So there's the summary. There are other things you can do with this if you explore a little bit. I direct to basically sort of the current analysis at one of the particular analysis. You can choose which analysis you want to have presented, and you can pick different times down here in the lower portion. So you can load a new sounding. You can, and these are fundamentally forecasts. The current forecast, the forecast for now is usually pretty good because it's based on measurements that were taken by lasers pointing down at the ground and getting the accurate result. And then, playing it forward in time, 20 minutes doesn't change it very much.
Mike,
You can get a forecast for what you'll see over time. And in the morning, what you'll see with the red line is it'll have a kink and it'll slant back. In the late afternoon, like we see right now, that's the air close to the ground has warmed up and is following that path up.
So the question was asked, how do you estimate how much the surface temperature is going to rise? And you actually just alluded to that a little bit.
Oh, I don't estimate it. I let the weather
No.
magicians estimate it. And I look at the max temperature of the day and work from that. So I'm not in any means an expert at predicting how much the ground gets heated up. I let the weather experts tell me what the maximum temperature today will be, and I use that.
Yeah.
If we back up to my website a minute, this is my weather. Come on. This is my weather page, and I just collect data from a bunch of different places. A current plot with radar and forecast plots with where they think the precipitation is going to be, and I get the whole day's sequence. If you grow it up, you'll see the times up at the top here of each of the plots. And so I get the sequence of what's happening with the weather as time goes on. You can put an airport identifier or a zip code for some things in here, and then you can click on the various different things I present to get different presentations. The one that we're looking at is this one that says NOAA sounding, but you get the textual weather forecast information on that one. You get the aviation forecast. Whoops, clicked on the wrong thing. I don't know. I don't think Fitchburg has one. Well, you get current observations on places that have them, and you get forecasts on places like, let me put Boston in here. No, let me put Worcester in there. And you get the forecasts at various times at the airport you've chosen. So I use the forecast information more for my power flying and pay attention to things that, the low level detail of weather that you need to know if you're going to do an instrument flight. Is it going to be 600 feet below the clouds, or is it going to be 1,000 feet or 200 feet? You really, you get that level of detail out of the forecast. So the other things that are on here, there's another source of the sounding. There's the New England Lyft Map, which is the blip maps that Dr. Jack produces. Now, I'm not logged in at the moment.
I'll go through this. I got it up.
You got those? Okay.
Yep. Yeah.
And I have tracking and Boston arrivals and so forth. Down at the bottom, I have the various aviation sources, ADDS, METAR information, winds aloft, quick links to get to things. And very far down, I have the sequence for many days in the future. And over here in the other links, you'll find all of the weather links that I have kicking around, and most of which I don't present on this top level page. And this is where anything that we come up with today in this discussion will end up on that other links page if I don't have it anywhere else. Well, there you go. It's all yours, Fred.
Thank you. Thank you, Mike. I'll be happy to continue to answer questions about the SKU-T. The log P comes in because the pressure is in a log format, and the SKU-T is because the temperature is skewed off to the upper left with rising altitude for the both the adiabatic and the saturated air. Any questions before we continue?
Yeah, I've got another 10 minutes or 15 minutes before I've got to disappear. So anybody got a question for me, better get it in now.
Yeah, go ahead. Anybody. Most of you have your mics off, so. And you can type them too. I got the chat up. Emily, did you get your question answered?
Yes, I did. Thank you.
Yeah, typically those plots, while they do show it for a particular time during the day, the ground temperature can be quite a bit higher, and it's that trigger temperature. If you don't have that trigger temperature, you know, of say, I don't know what it is, typically 1 degree or something like that. It's not a lot to get a mild thermal. I have been told that a ground trigger temperature of 2.5 degrees higher than what the curve shows is a very significant thermal. So if you think the day is going to be 85 degrees and the plot is showing an intersection for that time of day at 83 degrees, then you can probably expect pretty good thermals. Anybody? Okay, let me share. Just gotta find it. I've got all these other things here. Here we go. Okay, so Mike's information is really comprehensive. And as Mike said, part of it is because he flies power and all these other things. Mine is strictly focused on soaring, mostly in the lower half of New England, say from Connecticut up to the lower half of Vermont and New Hampshire. And you look at it and it literally says soaring weather links, and it says updated 9 of June. Actually, I updated it today. I forgot to do that. Some of this, so for example, if you can see my cursor, the WX Brief login, I use that pretty much only the morning of flying. So tomorrow morning, for example, I will log in there and I will look for NOTAMs and TFRs, special use airspace, anything that's changed, anything that I need to know about, closed runways, obstructions, you know, temporary flight restrictions, whatever it is, I will get it from there. That is a required login. The login is, you can register for free. And frankly, I never call WX Brief anymore. I pretty much use this exclusively. Now,
and a full briefing on WX Brief on the web does count as a legitimate legal briefing.
Yeah.
That's actually why you have to log in. It is in order for it to count as a legal briefing, they have to know who you are and what you looked at.
Yeah, and I typically will do what's called an area briefing for about 100 miles out. That's sort of what I like to fly. I don't go to the Canadian border. So let's take a look at the first thing I wanted to do, which is it's a week out. Where do you go? What do you do? And the answer for me is, and I'm going to click on these to show you what you get. This is the National Weather Service, and it's just there's kind of discussion of the weather. And it's a good thing to do because it has an update for the local area. It has highlights. It has the 4 p.m. update from Saturday through Thursday. You can read it through. It kind of gives you a sense of what to expect in the next week. Is it going to be really hot? Is it going to be really cold, et cetera, et cetera? It's just kind of informational. Now, going back, the next thing I look at, and don't laugh, is this. Here it is. What days look pretty good? Sunday looks like there's a 20% chance of rain. Yada, yada, yada. You can go down through here and say, well, some of these days might look a little better. Sunday looks like it's going to be blistering hot. You could make your own decisions. For me, it's typically, if it's 87 degrees, I'm probably not going out. I've sweated enough in my life, et cetera. And you can actually pick up little stuff too, like when it says mostly sunny. If that holds, it may or may not mean that there are cues that will form, but if it says mostly sunny, and somebody correct me if I'm wrong, if there is an actual percentage that they use for these words. So when they say mostly sunny, there's an actual percentage behind saying that. And I don't remember exactly what it is, but mostly sunny, for example, could mean 80% clear, 20% clouds. Partly cloudy could mean 50%. Mostly cloudy could mean 25% clear, things like that. There's an actual standard for that. Just keep that in mind that these are not casual words they use in these predictions, but they give you a sense looking out to say, Saturday might be a good day. It's mostly sunny. It's 83 degrees. That's tolerable. Sunday, maybe, etc. If we go further, Monday 30%, and then Monday night 40%. That would mean I'd probably look a little further and say what else is coming down the pike there. Again, it's the general overview for a week out.
And that's the same thing you get with the first button on my page.
Yeah.
You have to put an airport or a location in, and that's what you get.
And literally, there are some other things that I look at, and I will come to those down below. But if it's only about 3 days out, I look at what's called Fitchburg Weather. And I like Fitchburg Weather. Let me compress this a little bit, because it goes out about 3 days. So it has Friday, Saturday, and Sunday from current time. I like to see, hey, where's the wind peaking? It's only about 7 knots. There's a little bit of gust, but not much. Here's the wind out of the northwest. We're flying tomorrow, so I know the wind's going to be roughly out of the northwest. They're relatively light. They're pretty light with altitude. Later on in the week, you may see them go up and so forth. Here's something else I like. If you look at, where was it? Here's Friday at 2 p.m. So that's a good time through this column. Clouds at 6,000 feet. I got my fingers crossed that the thermals, I'll be able to thermal up to cloud base. We'll find out. And it's VFR. There's almost no chance of rain and so forth. And you can look out at least 2 or 3 days and say, okay, that's kind of the general weather that's coming up. It doesn't tell you the thermaling weather or the soaring weather, I'm going to use those words interchangeably, but it does give you a sense of what's happening, where the winds are from, if there's a crosswind expected, things like that. And I find that actually pretty useful. I use this, ADDS. This is a very common website. Just scroll down to here. I'm going to put in KORH. I'm going to decode it, and I'm going to include the terminal area forecast, get the METAR data, and there it is, the METAR data that's right now, and this is the prediction for roughly the next 24 hours. I generally do not look at this until the morning of. I might look at it the night before, but generally this is a morning of, and you'll also get the same thing through WX Brief. You'll also get it for any other stations that report TAF information, but there's not a lot around us that report TAF information. So Worcester's kind of it for more local, what you might call local flying. And if anybody has any questions at any time, stop me.
And this is exactly what you get with the NOAA forecast button, second button on my page.
Yeah. NOTAMs, TFRs, etc. I'll do the NOTAMs. Again, this is something I check the morning of or sometimes the night before. I go by a state. I typically will say, for example, Massachusetts, then I'll check Vermont. And this is the typical Hanover. I said this before, and I was always curious, why is Hanover forever on here until about 8 o'clock at night? And it turns out the reason why is because the Hanover Fire Department is the state's explosive disposal site, and they don't want you flying over that. You can click on the NOTAM, and it'll tell you what altitude that you're restricted from. You can fly over it, but it's like 4,000 or 5,000 feet. Odds are you're not going to fly down that way anyhow, since it's south of Boston, and that's not an area that typically sailplanes go to.
Wait a sec. Read carefully what's in the red bar. This is not a legal source for NOTAMs.
Yeah.
You must get your NOTAMs from someplace that is legal.
That's right.
This is not a legal source. You cannot use this to decide if there are NOTAMs pertaining to your flight.
The WX Brief site is the final authority on this. And what I do is I compare what they have against things like this. So I'll print off the area briefing I get. I'll scan it, I'll highlight things with a yellow marker. I'll keep it on my computer as proof that I did it, even though they log it. And then I'll go look at these sometimes to say, I wonder if they have anything different. Generally, they don't, but it's good to check. All right, let's, and you can do the same with special use airspace and so forth. A lot of it is redundant. Now, winds aloft can be useful. The problem is it's, you can get 6, 12, and 24. I typically will select Albany. Let's see if I can get that in here. If the winds are coming from the northwest, here's New York, Buffalo, Albany. And I'll typically go for a 12-hour forecast just to see what happens and get the forecast. There it is. Show you at different altitudes where the winds are. They're pretty consistent. I only typically look up to what I think the thermal altitude might be. And in this case, 3,000 to 6,000 feet is pretty normal this time of year.
The ADDS presentation you get to on the winds button on my side is much better than this, Fred.
Yeah, I use another one as well. And you can see at different altitudes what the winds are going to be. I occasionally look at this one. What I actually like is the wind map. And this is, and I use this one actually for quite a ways out. And I zoom in to Sterling Airport. So there we are. The winds right now at 7 p.m. are 3 knots out of the northeast at 3 knots. But here's what I'm interested in. So I'm interested, let's say tomorrow at 1 p.m. Where are the winds? Well, they're pretty light. They're 3K out of the west-northwest. That's good. They're pretty light. They don't change much during the day. They get a little heavier, 3 knots. What are they Saturday, et cetera, et cetera. But the nice thing that I'm actually looking for is Saturday, let's say at noon. They're cross, but they're light. Sunday at noon, and I actually write these notes down. They're 5 knots out of the south. Monday at roughly noon, they're 6 knots, but every now and then what you find is something like this. It's starting to pick up. It's 10 knots now, 11 knots, 8 knots, 9 knots, pretty mild winds. I have seen winds as high as 30 knots predicted close to the ground because the jet stream comes down. The other thing I like about this is that's at the surface. What is it at, here's 3,000 feet. Is it roughly the same? Yeah, it's not bad. 10 knots, 13 is picking up. 9 knots, so Saturday is pretty high. Sunday is not bad. Monday is not too bad. Okay, so here's Tuesday, 20 knots, but it's kind of mostly down the runway, so I'm not going to worry about that. Getting down to 25 knots, that's pushing the limits of what I would fly for winds at altitude. Not because you can't fly it in a high performance glider, because it just becomes, you're flying at 60 knots, your head speed into the wind is not very fast, you're not going anywhere. And frankly, if you get up high, you run the risk if you go downwind, especially in, say, one of the club gliders, of being able to get back to the field if you get too far downwind. Wednesday, 26, a little bit more cross. Tuesday, 23. So the winds aloft for the rest of the week, I'm just kind of eyeballing here. Hey, that's just something to be aware of. And maybe not so much to say it is or isn't flyable. The point here from a CFI perspective is, what are your maximums and minimums? I know people that will fly in these winds and just basically say it is what it is. Let's go have a good day. At least on the ground, they're not too bad. Other people may say, yeah, it's not worth it. But I do want to show you one more thing, and that is,
I got to leave, folks. Have a good night.
Yeah. Thanks, Mike. Thank you very much. The one other thing I want to leave you with is noticing where the winds are from. In general, if you have a northwest wind at 20 knots or a little bit higher, there is the possibility of wave. That's not any wave possibility. That's not. Oh, look at that. Wednesday, during the day, 26 knots. If you're willing to fly in that, stay upwind, you could get second or third waves off of the mountains in southern Vermont. They're a little bit further north. It could be even into, that's a possibility. It's getting a little lighter. And this isn't at all 3 knots. I guess we're not going to expect wave there. But it turns out that later in the week, if you're willing to give it a try, those 26 knots at 3,000 feet, I can't ever promise anything, but typically the rule of thumb is something above 15 to 20 knots in northwest to north direction in the Sterling area gives you the possibility of wave. And I will say that I haven't encountered any in the last year. So I use this both for long-term prediction and also for tomorrow. And I'll look at this first thing in the morning as well, as long as my other sites. Any questions? Anybody?
Fred, I have not a question, but it's good to have some wind at altitude just to line up the thermals, like in the
Yep.
mid-teens, even up to 19, 18.
Yes, I agree. And somebody asked the question about when do cloud streets form? And part of the answer to that is you can get, I don't know exactly all the parameters for it, but what you're looking for is an even airflow with altitude. And so both with the skew-T and this map, if you see the winds coming from a lot of different directions with altitude, you probably will not get cloud streets. But if the winds stay pretty much in the same direction, and whatever that direction is, there is the possibility of cloud streets because you need even flow at a range of altitudes to be able to get those clouds to line up. All right, let me.
Hey, Fred.
Yep.
That wave really is magical. Many, many years ago out of Sterling,
Yep.
I got wave with the wind at probably 4,000 or 5,000 feet was
Yep.
directly out of the south.
Oh, interesting.
That
is not what I would expect.
Exactly. I was aimed at Providence, okay,
Yeah.
right at the bottom of Wachusett Reservoir and going up into 8,000 feet.
Wow. So you all know George Young, or probably some of you know him really well. George's first flight ever with the club was with me in November, and we hit wave not from, but over Mount Wachusett and went up to about 10,000 feet. George landed and said, "I gotta do this." And he joined the club. And, the rest was history. But I was his first ride, and it was just fortuitous that we got into wave over Wachusett out of the northwest and made it up to about 10,000 feet. Okay, let me go back here. So I've gone through the wind map, the winds aloft. Now, the morning of, sometimes what you don't get in some of the predictions or looking a little bit long-term, and these upper atmosphere moisture loops and satellite cloud loops are really only useful for maybe a day, maybe at the most 2 days out, the way I use them. So let's take a look at this. I'm going to zoom in here. Whoop, a little bit too much. And the question is, what's the high cirrus? And a lot of times you don't get any indication of that on some of the predictions for thermal. It may say, oh, a great thermal day, and then this high cirrus comes in. This would say to me, there is minimal high cirrus coming in. The clouds are all going to the south. You could obviously zoom in on this as well. And actually, this can be useful. And it was, what was it, 2 years ago when they had the forest fires in upper Western Canada, and the smoke was coming across and was showing up on this as well. And it was really showing how bad the smoke was for Massachusetts. But I like looking at this to say, okay, looks like we got at least a day before this stuff hits So maybe this is going to be overnight. I don't really know. You know, that's, they said it's a scale of 500 miles, so that's a couple thousand, it's 1,000 miles out or 1,500 miles out this way. Depending on how it progresses and what happens, I can give you some indication that morning, especially if you zoom in a little bit to say, where's the high cirrus? Here, it's all south, so we're okay. Same with satellite clouds map. This isn't just cirrus, this is actual all clouds, and that can tell you, okay, there's, you know, I don't really know what these are here, thermal clouds or something, but there's a lot of flow down here. It's not in our region, so we're not getting any high rate flow from the jet stream that's dipping down. And this looks pretty good. It doesn't look like there's not a lot of cirrus coming in. That's my interpretation that morning. Right now for tomorrow, it doesn't help me much, but tomorrow morning I'll take a quick look at it and see if there's anything coming in. And then this one, I actually had to look this one up today because I was a little bit surprised by it. This is, well, there it is. This is how dirty the air is. And as you can see for New England, it's pretty clean. There's no forest fires, et cetera, et cetera. And then I got curious and I thought, well, that's interesting. We know there's forest fires out west, and sure enough, here they are. You can zoom in, it'll tell you where the forest fires are, et cetera. But then out of curiosity, I backed out. And this just astounded me. When was the last time you heard about all the forest fires up in the Alaska range? And I thought, gee, how come I haven't heard that on the news? So I Googled Alaska forest fires, and I guess it is a absolutely horrendous season for Alaskan or forest fires this year. And yes, these really are forest fires. So a little bit of information there you don't read about in the news because it's not the mainland USA. All right, going back down. So the fire and smoke map, if you really know or they're expecting smoke from the western fires, this can be useful. It isn't so useful right now because we're not experiencing smoke from the western fires. Okay, day of or day before, or at least in the case of the SkySight, 3 to 4 days in advance. The GBSC RASP I find incredibly useful. So this is Worcester, this is Sterling, this is the Hanscom restricted airspace. And we're looking at noon on Thursday. Let's go to Friday. And instead of looking at all these, I like to look at buoyancy over shear. And as long as we're somewhere around 2, 2.5 and above, it's a workable thermal, in my opinion. Now, the question is, what does buoyancy over shear mean? Thermals, as they rise, give you an indication of buoyancy by how strong they are, but wind shear can blow them apart. So the question is, you can have a really weak thermal that is more workable on a calm day than a very strong thermal that's being blown apart on a wind day, or you can have similar. So the buoyancy over shear gives you some sort of indication of, given this wind strength and the expected buoyancy of the thermals, this is what we can expect. And so far for noon tomorrow, it looks okay. 1 o'clock looks a little better, but then there's this trough here, but we kind of expect that. Of course, it's over Sterling. And then it gets a little more spotty. It's really good, but you know, there's large areas of decent enough lift, et cetera. And it will continue. This is 3 o'clock, and here's 4 o'clock. And then after about 4 o'clock, all this stuff starts moving in. And let's see what goes at 5 o'clock. It's probably dying, and you should be home by then. That's for tomorrow. Let's look at Saturday, and let's start with noon. Saturday at noon, buoyancy over shear is it's probably workable. If you click on the map, it goes to 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, et cetera. Supposedly not as well, but the skew T gives you a different story. So let's pick a time like 1 o'clock on Saturday, compare it to Sunday. Sunday looks pretty good. Look at that. Monday, probably not. Tuesday at 1 o'clock, probably not. Wednesday at 1 o'clock, Wednesday is a possibility at 1 o'clock. Now, this is just one snapshot into the future, but so far it tells me, watch Wednesday for next week, but keep in mind it's New England, it could snow. Now, the other thing to look at is what's the critical height. So it may look like it's a pretty good day, but where are the thermals? And the answer here for Wednesday at 1 o'clock is somewhere in the range of 4 to 5,000 feet, something like that. And then watch as they rise, but then you get these pockets of non-thermal activity, et cetera. So let's go back to Friday. Friday at noon, weak thermals, but probably workable to maybe 4,000 feet, three to maybe 3,500 to 4,500 feet. That to me says good enough. 1 o'clock, okay. 2 o'clock, starting to get more holes. 3 o'clock, a lot more holes. And then as you progress to 4 o'clock or 5 o'clock, it gets quite a bit worse. Saturday, that's 2 days away. 11 o'clock probably would not launch. Noon definitely would launch, but I would not go to the west so much. I would go more north. 1 o'clock, much broader area. This is Amherst here, so you have Gardner, Orange, and so forth in through this area. This looks like really good. This is Jaffrey, by the way. And so you have a lot of area here to play with heading north. Can you make it home? Probably. Looks like the Connecticut River Valley isn't working so well, but if you stay over New Hampshire, you'll have a nice long day of soaring. One other thing I checked is, and I'll go back to Friday again for this, surface winds at 2 meters, pretty light, 2 to 3 knots, and then boundary level wind, pretty light, 5 to 6 knots, something like that. So I can use this to look into the future a little bit and say, okay, these are the days to look at, but don't make any hardcore decisions yet because things can change. And last but not least, these are the soundings. And these soundings are just like what Mike talked about. So here's the sounding for tomorrow at noon. And the downside of this sounding is it doesn't have an interactive cursor, so you can't just click on it and say, hey, what is it? It's going to be about, 26, 27 degrees centigrade. It's got a nice cooling. If you go, this is about 4,500, 5,000 feet, 850 millibars. So somewhere in the 4,500 to 5,000 feet range, you're probably going to get clouds because the dew point and the temperature converge, and that's where the moisture comes out of the air. And the air still is cooling, but it's basically an inversion at that point, so you're not going to climb any higher than what your sailplane can do based on its minimum sink rate. So now keep that in mind. Here's 2 o'clock. So deeper area for clouds, so the clouds are going to be higher, and then you'll hit the inversion. The place where the clouds are lifted a little bit, 4 o'clock, a little bit more, and so forth. What's Saturday look like at noon? It's actually soft. So Saturday at noon, it's kind of following the dry 80 about a cooling rate. And then right around here, it doesn't cool at the same rate, which is why that purple line is there. And the dew point is kind of hokey there. But let's take a look at 2 o'clock. Look at that. All of a sudden at 2 o'clock, the day may take a little bit of time to develop, but you're going to be able to hit 5 to 6, maybe 7,000 feet if it gets really good tomorrow and if these are conservative, ideally. Sunday should be soarable as well. Keep an eye here, though, 10 knots out of the, excuse me, it looks like out of the southwest. Monday, here you get to be a problem because the winds immediately, not too far above the ground, hit well above 20 knots. Tuesday, yada, yada. You can just go through this and play games and compare notes. Okay. The other one that's useful is Dr. Jack gives you similar information. You can take a look at that. You have to register for it. So you register on this link, and then you can go to the extended forecast, which gives you today, tomorrow, and the next day, or the rapid update cycle, which just gives you that day. SkySight, this is a paid service, but it's kind of minimal. I've been learning more about how to use this. This is how I use it. I click on point forecast. I click somewhere around the Sterling area, and I ask the question for today, what's the thermal heights? Soarable heights. Okay, it looks pretty good. Tomorrow, what are the soarable heights? And this is what's interesting. They may say at some point 700 feet soarable height. I personally believe that SkySight has been too conservative lately. I think it's off. It's probably correctly predicting for that exact spot or close to it. But I find that SkySight, the last few times I've looked at it, compared to the GBSC RASP or Dr. Jack and RASP have been more accurate about the nature of lift. That's Friday. This is Saturday coming up. Saturday looks pretty good from about, let's say, 12:30 till 4:30, and I should be able to hit 5,000. Some of the other plots say 6,000 or so. Here's Sunday, not looking so good. Monday, etc. So I kind of look at this going into the future, but I've been a little bit disillusioned with SkySight, relying a little bit more on RASP and Dr. Jack recently. That's me. Other people use different things. Let's kill that for a second. You can use other things here. So for example, let's get the skew T for Friday at noon. Let's get the skew T. This is, come on. So this is the skew T for Friday at noon. Good cooling. If the ground temperature is even, this is set for, I think, 68 degrees roughly. If we go up here to, oh, I'm sorry, it's 70, it's expected to be 73. If it's a little hotter, it's supposed to be, I think, 83 or so tomorrow. Then you definitely will get thermals up to, let's say, roughly 5,500 feet. Okay, that looks good to me. What about at 2 o'clock? 2 o'clock, and I notice I'm not going all the way up because you know, the thermals may be still rising, but the clouds are forming and I can't go into the clouds. So I back off a little bit. And remember, this is just guessing here. Looks like 6,000 feet by 2 o'clock, 3 o'clock. Let's try 4 o'clock. Not much different. In fact, about the same for 4 o'clock. So about 1 to 2 o'clock, you're going to hit your peak altitudes tomorrow. Winds will be relatively light. It's going to be warm, but looks soarable to me. You can do things like, if you're cross country, you can say potential flight distances, which tells you, hey, roughly you could probably fly this far. Play around with this site. If you subscribe to it, I would encourage you to subscribe to it for a year. Give it a shot, see what you like, what you don't like. And that's how I do it. And so I kind of start with looking a few days out, not making any decisions, kind of eyeballing which days to watch. So for next week, I'm going to watch Wednesday, but I'll watch either day. I'll watch Tuesday and Thursday, both sides of it, because the fronts could come through earlier. They could come through a little bit later. And as we saw this week, we thought Wednesday was going to be a 20 to 22 knot crosswind. It ended up being a gorgeous day and not that, but we didn't know that till that morning. So keep your options open. And that is how I do it. Open to questions. And everybody has their mic off. So.
Yeah, hey Fred, if you could go back to the RAF site, maybe I missed it in your presentation, but there's a couple different models and timeframes for the models that the RAF site has. So could you bring that back up on your screen? Yeah.
It won't let me minimize, so I have to go to, oh, interesting. It won't let me. How do you like that? Let me try this. Trying to find where it is, and it won't. It's not coming up. More. Let me try more.
Actually, I could, might be able to.
See if you
pull
can
up here.
bring it up.
Yeah.
Okay, I'm not having a lot of luck here. I accidentally closed the window. There you go. Thank you.
Yeah, okay. Yeah, well, let me get this out of here. I'm not sure what's displayed. So there's a couple different models and time periods that the forecasts are for. The GFS is, global forecast, something or other, I don't know.
Yeah,
But
yeah.
the resolution of the little resolution of each forecast little block is somewhere about 28, 30 kilometers on a side. So it's takes like a bigger surface area, if you will,
Yes.
as it does its plot. The next one, the NAM runs out. GFS runs out, I think, basically 7 days. 1, 2, 3, 4, 5, 6, 7. Yeah. NAM runs out. Well, it shows 4 here.
Yeah. By the way, I do use NAM a lot. I just forgot to mention that.
Yeah, the NAM is about a 12 kilometer block, so a smaller block, a bit better resolution, or at least I like to think on the how the forecast is created. WRAP 1 day. Again, that's like 12 or 13 kilometer resolution.
And that stands for
And
rapid update something or other.
yeah, and HRR is a smaller resolution yet, or a smaller little block of terrain at 3 kilometers. But it's only comes out for the one, the current day. So if you want to look at far out, like, how's this next Monday, Tuesday, you'll be using GFS. As you're looking closer, try to use the most current model. And if you're looking, I'm not sure if HRR is produced like at 8 o'clock in the morning, or might come out a bit later, but try to use whichever the model is most current, most appropriate for the day you're flying.
Perfect. Thank you. Any other comments? I am by no means an expert, and I'm gonna.
So I'm the one that created all of those maps.
Yeah.
Yeah.
And Eric, by the way,
Um,
has a app for your phone that I included in my email that you
Yeah.
can use, that he's been updating as well.
Yeah, well, yeah, and
So there's some.
I was just going to say, I basically
Come
take
to the mystery.
Oh, sorry,
Yeah.
Steve. What's that?
Go ahead.
Oh, all I was just going to say was the app just basically takes all the forecasts that Steve Pavola's site creates, or the RAF site, and presents them. So whatever information you get on, on the app, it's basically identical to what you see on the website.
So some history of the Club RASP site. This all actually started with Dr. Jack. And Dr. Jack created sort of some base code that was producing maps. And then there's a guy in England, I'm not spelling out his name right now, who took that and made it more generic, figured out how to produce more information. So for example, the GFS forecast comes out every 6 hours. The GFS covers the world. GFS goes out, I don't know, 15 or 20 days. I'm only producing a week's worth of the plots. I'm actually running the weather model, starting with the GFS plots, to produce sort of interpolated values every hour. So the GFS, you see that on the club website, that with GFS, you can see every hour worth of data, but that's not what NOAA produces off of their supercomputers. Talking about NAM a little bit more, NAM runs again every 6 hours, but it produces information out it's a somewhat different model, and it produces information out, I don't know, I forget, 48 hours or something like that, 60 hours. It's like 3.5 days worth of data that it produces. NAM, again, runs maybe I'm wrong about this. I'm forgetting how often NAM runs. NAM may be running every hour, but it produces information out about 24 hours. HRRR is the so-called high resolution rapid refresh. That's what HRRR stands for. It runs hourly, but it only produces information out 18 hours. So I'm trying to extract, part of what is going on when I do my runs is I try to extract the information from these models and produce information that's useful to the club and to anybody else that wants to use it. But I do a run every 6 hours to update the information that's on the website. Now, it may be the case, HRRR seems to be more optimistic in terms of, if you look at what the cloud heights, the thermal heights are and so on, it seems to indicate higher altitudes. It may be more accurate, but I don't know that's the case. I know other people like what GFS produces. And I don't know which of the 4 models actually produces the best information. What I sort of like to do is compare what the 4 are doing to get some level of confidence as to whether I have good information about what the next day is going to do.
Yep. We have Steve and Eric to thank a lot for a lot of weather information. I have a question here from Kathy, who says, I'm interested in how often we see convergence lift on the local Sterling area. Is it really good? How do you know? And yet I've heard Bob Fletcher and others talk about it. Anybody want to talk? I know Rick Rolke told me once he hit some convergence lift somewhere over Wachusett Reservoir, and he took it all the way back into halfway up New Hampshire or something ridiculous like that. And then he turned around and flew back. How do you know? Anybody want to talk about that?
Well, can I share my screen a little bit?
Sure, anybody can share.
Let's see if I can figure out how to do that. Because
There's-
actually there is a way of seeing what the predicted, you see the RASP share site?
Oh, there it comes.
So
Okay,
hopefully
there
you
we go.
see that.
Yep.
Okay. Let me see if I can find it. So these are sort of the short list of the plots that I produced, but there is a longer list.
Uh-huh.
So you click on, so there, this is the long list. And here is a convergence plot. So this is sort of saying, well, where are the winds converging to produce lift? So
It looks like over the Connecticut River to the east of it, because it's going up through Claremont and stuff, might be an area.
yeah, that's next Tuesday. I will comment that on Sunday, this showed a very clear convergence from sort of the Boston TCA up to Portsmouth, New Hampshire.
Wow.
And there was a very clear cloud line marking all of that. Unfortunately, it's all controlled airspace, so nobody actually tried to use it.
Interesting.
I'm just
So
going
there
through
is
some of the
weak
days to
convergence
see.
shown, but not a lot of strong convergence. Yeah, that's probably the best
So
one.
Tuesday next week, it might have something stronger.
Yeah.
It's not a very common event,
Yeah.
but what I'm pointing out is that in fact, the RASP website does show you where there's potential for this stuff,
Yeah. Yeah. Thank you.
if you know how to look for it.
Yeah. Thank you. And of course, it changes by the hour or the half day or whatever. So you really
Mhm.
gotta just kind of, for example, you're looking at what is that, Wednesday next week at 3 o'clock. Wednesday next week, like kind of humorously say, it could be snowing.
Yeah, the Perline project is trying to use some of the same information for guessing where the updrafts are going to be over South America.
Yeah. All right. Other questions? Anything?
Hey, Fred, so usually good soaring days can end up with overdevelopment. How can you tell whether the good day is going to end up badly?
I think RASP and several of the other sites actually have a overdevelopment indication. Cumulus cloud base where potential, but several of the websites have a tab you can click on for overdevelopment. Overdevelopment isn't necessarily a bad thing. It just means that there's lots of clouds everywhere and you're going to have to find the thermals. It is what it is. I personally don't worry about overdevelopment until it gets fairly uniform, in which case then it's really hard to find a thermal because you don't know where the heck they are or what's working or what isn't. It's always frustrating when you got like 80% cloud cover and you go under a beautiful looking cloud and it's completely dead, and then you go out over another cloud and you hit a thermal and you think, okay, why is this one here and that one isn't? So I don't have an answer for that.
Yeah, I try to take a look at overdevelopment and sometimes, when you get really strong thermals, you end up with overdevelopment. Although, taking a look at both RASP and SkySight also has the equivalent plot. The last two times I was flying, taking a look at what I remember looking at the SkySight overdevelopment, and it never happened. So you just sort of have to take it with a grain of salt. I guess if you see it on the forecast, okay, it can happen. And certainly if you go up into New Hampshire a ways, at least I'm always looking back over my shoulder to see whether, what it's looking like and am I going to be able to get back home or not.
Yeah, I do that too.
Yeah, but again, it's sort of the weather is what you find it at the time as opposed to what was forecast, and not always the same. So
I will comment further that I did my diamond distance flight with the entire distance from Keene to Claremont, New Hampshire, and back again, quote, overdeveloped. What I found is that if you go and fly towards the dark spots in the clouds, there's lift. That was one of the faster legs of my entire flight, was going to look for the dark spots and the overdevelopment.
Yeah, but let me interject. The last time I flew, until they're not.
Well, yeah, there's another example of where I went and found all of the nice overdevelopment spots and flew from Springfield, Vermont to Keene and had a nice time. And then Fletcher's heard my reports on the radio and said, tried to do the same thing. He said, I almost didn't make it to Keene. So yeah, you got to be a little bit careful about that.
yeah, if you find you're stuck under the overdevelopment, it's best to throttle back, try to stay as high as you can, try to work some of the clouds suck. And as Steve said, go to the darker parts. No guarantees, but yeah.
I mean, isn't the overdevelopment usually followed also by thunderstorms, lightning, gusts?
No,
rain?
no, again, taking the last few weeks as example, it could be that, good thermals lifts up the moisture. You just get so much activity, you get a, pretty 100% cloud cover, cuts off the thermals, air dies, and eventually the clouds start to dissipate, and then it might cycle again, or, give it some time, although it might take longer than you can hang up, at altitude. But yeah, it doesn't necessarily mean you're going to get thunderstorms.
Any other questions or comments? We've gone, looks like at least an hour now.
Question on the RASP. When it's calculating the locations of like the lift and the sink and the thermals, how does it get the geographic information? Is that just based on a topo map?
Yes,
don't know.
RASP has a topographic map that it uses for the computations.
Okay, so the areas where we're saying is high lift are just over higher areas where the warm
Yeah, yeah.
air starts at a higher altitude?
Yep, it knows about that. So absolutely true. I brought up this skew T log P plot. What you see here is nice strong lift to whatever it is, 4,000 or 5,000 feet. This dashed line is what potentially the air mass, a bubble of air will do if it makes it this high. So it goes from a dry air adiabatic elapsed rate to a wet air.
Yep.
And notice that it can potentially goes up to stratospheric altitudes. So this is what you look at to see whether there's a potential for a thunderstorm. Because there's nothing stopping this bubble of air from going up to really high altitudes.
Yeah, there's no inversion there.
Right.
Yeah,
Now, it didn't
that's-
happen
that's
today.
Thursday.
That's
Yeah, it
just a
didn't happen.
potential.
So you have to make your own judgments. You have to take things with a grain of salt. And the way I do the grain of salt is I compare multiple sites and try to get a sense of what is the commonality between them. Then I cross my fingers and go to the airport and fly. So, the last couple times I have flown, I will say that SkySight predicted a modest to not very good day. RASP said pretty good day, and they ended up being pretty good days. It's just what it is.
Yeah, I would sort of reinforce that in terms of, the weather models are weather guesses as to what's going to happen. If you make a decision to not fly based on the weather models, you will get what you decide on. You may miss out on some really great days.
Anybody else? Any questions? I don't want to hold people here too much longer.
This is Ravi. I have a question. So the glider flying handbook, a chapter on soaring weather, has all sorts of indices like the thermal index, the lifted index, the K index. And I was wondering where we can get these from. I noticed that the skew T plots that Mike Newman had a whole array of different indices, like the CAPE and the TI listed at the top. But is there a source to get this type of information that the FAA appears to be suggesting?
Anybody want to answer that? I cannot answer that.
Yeah, the FAA does not, well, the FAA, not FAA, NOAA does calculate CAPE. And that could produce that plot as well. CAPE is basically the probability that you're going to get thunderstorms for the day. The TI is a glider specific thing. TI is basically the difference between the dashed line here and the solid line.
Let me point out that when I've called WX Brief, on occasion, I've actually asked them for the thermal index. And some briefers can find it and tell me, and other briefers cannot. So,
yeah, I sort of like these things because it shows you what the mixing layer is. This is sort of how high it's going to be before the thermals are going to go.
Yep.
This shows nicely that we ought to have thermals up to about 5,000 feet. That's what this QT log P shows me.
yeah.
I've also seen some other discussions saying, well, the thermal strength is often predictable by how tall the thermals are. So if I've got a 5,000 foot thermal, then it's probably going to have very strong lift up to about 5,000 feet.
Yeah.
If I've got a day which only has 3,000 foot thermals, then the thermals are going to be weak in terms of what the rate of climb is going to be.
Anybody else? Questions? Okay, I am actually going to stop the recording. I want to thank everybody for being here.